Okay. All right, so welcome everybody to SICSS, Summer Institute in Computational Social Science. Hello to everyone in Chicago, to everyone in Seattle, Cape Town, Helsinki, and New York. We're all really thrilled to have you here, and we're going to kick things off today with a lecture entitled Introduction to Computational Social Science by my collaborator and partner in crime, Matt Salganik.
So we thought we would start by trying to answer this question, which is a question that we're asked frequently. In fact, some of you asked me this last night. So let's just start right off with the hardest question. What is computational social science? And I have a clear answer to this question, which is anything that's cool. Now, why would one sort of define something in this way? I think the important point to keep in mind is that it's still very, very early in this field. And so to try to define something would be to create an inside and an outside. And I don't think there's any reason to create an inside and an outside yet. And I could imagine 5 years ago I was in conversations like this, and if we had tried to define the inside and the outside, we would have made some very bad decisions. So our plan is to keep an open mind and see how things evolve, because they're definitely moving very quickly. So if any of you here are doubting that you are computational social scientists, you are all computational social scientists. So that's the answer to that question. But we do have a more slightly serious answer, or so what are some themes that seem to be happening in computational social science? So this particular study, I think, illustrates many, many of the themes that I see in computational social science, all packed into one really interesting paper. So this is by Josh Blumenstock and colleagues, and it was published in Science about a year ago. And it's about predicting poverty and wealth from mobile phone metadata. And so just to sort of set the context for what they're trying to do, let's imagine that you wanted to eliminate poverty in the world. Okay, so that's a goal many people could probably get behind. One of the many, many, many problems that you would have is that we don't even know how much poverty there is and where it is and how much it's changing. So measurement problem on top of all the other problems. And so in the past, there's kind of two ways that people make big social measurements. So one would be through a census, where you would go and you would interview every single person. And censuses are great because they allow you to get very granular, small area estimates. But they're slow and very, very expensive. And so the main alternative to census is doing a sample survey, where you would interview a random sample of people. That's much cheaper and faster, but it doesn't necessarily allow for very small area estimates. And so what if there was a way that you could create a measurement system that had the granularity of a census, but
Okay, we got the slide off. Okay. All right, so welcome everybody to SICSS, the Summer Institute in Computational Social Science. Hello to everyone in Chicago, to everyone in Seattle, Cape Town, Helsinki, and New York. We're all really thrilled to have you here, and we're going to kick things off today with a lecture entitled Introduction to Computational Social Science by my collaborator and partner in crime, Matt Salganik.
So we thought we would start by trying to answer this question, which is a question that we're asked frequently. In fact, some of you asked me this last night. So let's just start right off with the hardest question. What is computational social science? And I have a clear answer to this question, which is anything that's cool. Now, why would one sort of define something in this way? I think the important point to keep in mind is that it's still very, very early in this field. And so to try to define something would be to create an inside and an outside. And I don't think there's any reason to create an inside and an outside yet. And I could imagine 5 years ago I was in conversations like this, and if we had tried to define the inside and the outside, we would have made some very bad decisions. So our plan is to keep an open mind and see how things evolve, because they're definitely moving very quickly. So if any of you here are doubting that you are computational social scientists, you are all computational social scientists. So that's the answer to that question. But we do have a more slightly serious answer, or sort of what are some themes that seem to be happening in computational social science? So this particular study, I think, illustrates many, many of the themes that I see in computational social science, all packed into one really interesting paper. So this is by Josh Blumenstock and colleagues, and it was published in Science about a year ago. And it's about predicting poverty and wealth from mobile phone metadata. And so just to sort of set the context for what they're trying to do, let's imagine that you wanted to eliminate poverty in the world. Okay, so that's a goal many people could probably get behind. One of the many, many, many problems that you would have is that we don't even know how much poverty there is and where it is and how much it's changing. So measurement problem on top of all the other problems. And so in the past, there's kind of two ways that people make big social measurements. So one would be through a census, where you would go and you would interview every single person. And censuses are great because they allow you to get very granular, small area estimates. But they're slow and very, very expensive. And so the main alternative to census is doing a sample survey, where you would interview a random sample of people. That's much cheaper and faster, but it doesn't necessarily allow for very small area estimates. And so what if there was a way that you could create a measurement system that had the granularity of a census, but the speed and flexibility and low cost of a sample survey? And so, or more generally, what if you could have some kind of system that was like a ubiquitous, always-on survey, where you could be surveying every single person in the country every single day and having this nonstop measurement system? So that is like that is not what they did in this paper. That would be really cool. Just to set expectations, that's not what's coming next. But what you'll see is you'll see this as a step in that direction. And they did it by using ideas that are common in computational social science. So let me talk about, so the study took place in Rwanda, and they started with the call records from the largest mobile phone provider in Rwanda. So they have records for about 1.5 million customers, very detailed records. Every call, what time it started, what time it stopped, who was the sender, who was the receiver, and what was the location of the sender and the receiver. They also have information about texts, and they also have a bunch of billing information. So then they did, but this call record, this sort of, we could call this big data. We'll talk more about what big data is later, but we'll just call this big data for now. This big data, though, did not actually have the thing that they cared about, which was a measure of wealth of these people. It had something that's correlated with the thing that they cared about, but not the actual thing they cared about. And so they took a random sample of people from these call records, and they interviewed them and did a survey with them. And so they gave them a well-developed scale for measuring poverty in developing countries. So this data here is what we might think of as big data. This data here is what we might think of as traditional social science survey data. And then what they did is they linked them together in a way that allowed them together to do something that neither one could do individually. And so here's how they did that. So they took the call records, and then they did a process that's called feature engineering by data scientists, or you could call it, I guess social scientists might call it data cleaning or data preparation. And so they created a big matrix where there's one row for each person and one column for each feature or variable. And those variables could be things like number of outgoing calls, number of incoming calls. But they can also be very sophisticated and complicated features like, of the people that you've called on a Tuesday, how many times do they call each other? And so they built many, we'll talk a little bit more in detail later about how they did the feature engineering, but it was a combination of sort of feature engineering by thinking about the world. Like you might expect that international calls are a different indicator of wealth than domestic calls. So that's in there. But then there's other stuff that's more data-driven where they sort of say, well, maybe Tuesdays are different than Thursdays. I don't really know. Let's just throw it all in there and sort it out in the machine learning. So they built this big matrix, and then they trained a machine learning model to estimate what you'll say on the survey based on the characteristics of your calling behavior. And then, again, there's some interesting machine learning here, which we'll talk a little about later when we talk about surveys. So then they use that model to then impute or guess the survey responses of everyone else. And so by interviewing 1,000 people, they're able to, and combining it with this other source of data, they're able to approximate the responses of 1.49 million people. Then they're able to put all of these people onto a physical location. They estimate where they live based on the tower. Roughly what they do is they look at the towers that you call from at night. And that turns out to be a pretty good proxy for where you live. And so you put all of this together, and now you have a system that allows you to get small area estimates of poverty in Rwanda using a relatively small sample. So how well does this work? That's always a question you should ask when someone shows you something you haven't seen before. And the answer is it works pretty well. So there's a couple different ways to evaluate it. And obviously, the paper has all the details, so I'm going to give a very short summary. So one thing you might want to check is for the people who are in the survey, let's pretend that we don't know some of their answers and see how well we can correctly recover them. So this is related to the idea of cross-validation, which is something we'll hear more about a lot. Not very common in social science, very common in data science. I think will become increasingly common in social science. And so this is showing the results of cross-validation. So this is the predicted wealth. This is the actual wealth. And you see there is some pattern. They're able to get some signal from this digital trace data. But this isn't actually the thing that they care about. This is, we don't care about can we predict for this sample of people what they're going to say on the survey. We really care, can we make this estimate for Rwanda? And it's not clear that these two things are the same. So for example, it might be the case that people who have cell phones are more wealthy than people who don't have cell phones. That'd be a very natural thing to be worried about. So even if this was perfect, it might not actually do what you care about. So now, how could we check whether it actually does what we care about? So it's fortunate that a few years before this, there was a demographic and health survey in Rwanda. And so for people who don't know, the demographic and health survey is a very traditional, expensive social science survey that uses sort of gold standard methods. They do probability samples, face-to-face interviews. The interviewers are very well trained. This is kind of like the best we can do using available methods. Thank you. And so the question is, how does this hybrid of this sort of big data source with a small amount of survey, how does that compare to the demographic and health survey? And so here are the results, actually aggregated to the regional level. So and so what we see is for the 30 regions in Rwanda, the predicted wealth and the actual wealth computed from the Demographic and Health Survey, they line up reasonably well. There's more detailed analysis in the paper. We should also remember that the Demographic and Health Survey has errors as well. This is not like the truth. I mean, it's good, but like this is not the truth. So wow, seems to work pretty well. And there's another thing which I didn't say, which is that the hybrid approach is 10 times faster and 50 times cheaper. So many of you mentioned, you're excited about finding stuff that you can do maybe more inexpensively, opens up a lot of possibilities. I think we should remember, though, that reducing the cost is not an end in itself. It's potentially a means to an end. So what would it mean if you could reduce the cost by a factor of 50? Like, it does not mean that we should cut the budget of the Demographic and Health Survey by a factor of 50. That would be a really bad idea. What it means is that we should collect 50 times more data. So Demographic and Health Surveys now happen every 5 years, roughly. But in wealthy countries, we don't have to wait 5 years to have snapshots of our population. We have unemployment rate estimate, for example, every month. So instead of doing a Demographic and Health Survey every 5 years, why not do one every month? That would open up a lot of opportunities for researchers and create a lot of valuable data for policymakers. So whenever we talk about cutting costs, let's also think about to what end that would help us achieve. Now, I should also be really clear. This is not a fair comparison. This is not an apples to apples comparison, because the Demographic and Health Survey uses probability sampling techniques where there are theoretical guarantees, and where there's like 50 years of practical know-how and experience in making these estimates. And so we should have a lot more confidence in the estimates that come from the Demographic and Health Surveys because of those theoretical guarantees and because of that experience. But I think within the next several years, we will see much more of those kinds of things to think about these newer kinds of data collection and analysis techniques. So those theoretical foundations, we are the ones who will have to develop them, and we are that practical expertise and know-how, that's the stuff that we are going to have to create. So a couple of themes that come up in this study, it is both computational and social science. So there is some machine learning stuff that social scientists don't normally do. There's also some social science stuff that doesn't usually come up in machine learning. So there's original data collection using well-developed scales. They didn't say, oh, well, we have this data. Let's see what we can do with this data. They said, we have this data and we have this goal. Let's get some more data so that we can use the data that we have to achieve our goal. It involves complex ethical and privacy questions. So let's imagine that you really loved hearing about this study and you wanted to do this. You are not able to go on the internet and download all of that data. For good reason, because that data contains a lot of potentially sensitive information. They had to get this data from a company. They were very responsible in how they treated this data, but this is a challenge that arises many, many, many times. This project is a beautiful example of combining ready-mades and custom-mades, and so let me explain what I mean by that. So this, as you all know, is a urinal. It's a very famous urinal. It's not just any old urinal. So this is Fountain by Duchamp. And so this is one of my favorite pieces of art because it changes sort of what you think is possible. And a lot of work in data science reminds me of this urinal in the best way, the most positive way. Because it's very creative and it changes what you think is possible. So Duchamp saw that urinal that was created for one purpose, and he said, you know what? I can repurpose this and do something else. And so through that process of repurposing, he opened up lots of new possibilities. Now, this is not the way that social scientists normally work. And so if I had to think of a piece of art that captures the social science style more, I would think of this, David. So when Michelangelo wanted to make David, he didn't look around for a thing that kind of looked like David. He spent 3 years making David. And so this is the sort of custom-made style that a lot of social scientists have. And so if you are a social scientist, though, I think you will realize that it is increasingly hard to go with a pure custom-made style when there is more and more ready-mades available. Like, it just becomes impossible to ignore. You can pretend that that stuff's not out there, but the way the world is changing, this style a pure custom-made style becomes very hard to do. And for the people that are used to working with ready-mades, I think increasingly they will see that there are not many fountains. Like, there's a lot of junk, and there are limits to what you can do with clever repurposing. And so I think increasingly what we'll see is a hybrid of these two styles, and that's exactly what happened in this Blumenstock study. So he started with the call data. That was a very clever repurposing, but it didn't do exactly what he wanted. And so he also collected this survey data, which allowed him to achieve his goal. And the survey data alone was not enough, and the call data alone was not enough. And so this combination of ready-mades and custom-mades is something that you'll see a lot, and I think we'll see increasingly more of in the field. Also, the Blumenstock study involved 5 different communities that I think are going to be really key to computational social science, and figuring out ways that these communities can work together is very important. So it involved social scientists and data scientists. It involved business people, privacy advocates, and policymakers. So these are the 5 different communities that we see a lot in these studies. And I think a key for computational social science to thrive is for these communities to stay in appropriate balance. So imagine a world where there's computational social science that doesn't involve policymakers. So that's probably not a good idea. It's probably not going to deliver on the promise of helping make the world a better place. Imagine a world of computational social science where there are no privacy advocates. That is also a pretty scary thing to imagine. I think if business people are not involved, that will also not work very well, because they have access to a lot of the data that is necessary to make this go. If data scientists are not involved, then many of the capabilities of this data will not be used successfully. And if social scientists are not involved, I think there's a great chance that there will be not the most important and interesting questions will be asked, and not the right conclusions will be drawn. And so you have to really figure out ways that these 5 communities can stay in balance, and that we want to end up with a healthy ecosystem with all of these groups sort of pushing and pulling and feeding off each other, rather than a kind of monoculture where one thing just takes over. And so that's part of explicitly how we've structured the Summer Institute, to try to create this healthy ecosystem and not a monoculture. So that's a little bit of a more serious answer as to what is computational social science. I think these are the kinds of themes that I've seen a lot of, and that I think will be increasingly common as we go forward. Another question that I get asked a lot is, well, isn't this all just one big fad? Because it seems like it could be a fad, like it's very fast moving, there's a lot of interest, there are people who won't define it very clearly. That is like a good sign of a fad when someone says, yes, whatever, it's anything that's cool. So the answer to this question, I also have a clear answer, which is, I think it is no. It is not a fad. And let me explain why it is not a fad. And it's with this picture. So this is from a paper by Hilbert and Lopez, and it's the amount of information in the world. This is like kind of a weird quantity to estimate. But in this paper, they go through in great detail to try to figure out how much information there is in the world. And the graph here shows two really distinctive patterns. So this is 1986. This is 2007. So you see two patterns. One, the amount of information is increasing a lot. And two, more and more of that information is digital rather than analog. So this green is the digital slice. And the other thing in this paper, they estimate that the amount of information doubles roughly every 2 years, similar to Moore's law. And so imagine now we go out from 2007. So in 2009, it would double. In 2011, it would double. In 2013, it would double. In 2015, it would double. In 2017, it would double. So I think that's like 5 doubles. So 2, 4, 8, 16, 32. So this becomes even impossible to draw. And there is very little reason to believe that this will stop or slow down. So try not just to think about what the world is like today. Try to think about what the world will be like 3 years from now, 5 years from now, 10 years from now. If you're graduate students, what will the world be like when you are coming up for tenure, let's say, if you decide to become professors? So I think this, to me, is a very exciting thing about not just what is happening today, but where things are moving. And to me, one of the most exciting parts of computational social science is not the current level, it's the rate of change. So I see the rate of change is much faster in this part of academic life than in many others. And I think that will continue for a while. And so this picture has nothing to do with any of us. It has nothing to do with funding agencies or foundations or anything. This is going to happen regardless of what people do. So a lot of academic things, what we do in this room, I should say. Like a lot of academic things are driven by things happening within academia, right? And those can be fads. Those can come and go. This is not going anywhere. So I think as researchers, we have the option of taking advantage of this huge rush, this huge momentum of stuff, or we can really get left behind. Now, that is not to say also that there are no fad-like elements. So I think there are, in fact, some fad-like elements in computational social science, and I think this picture is the best way that I've seen to sort of summarize what I think is happening. This is something called the hype cycle by a company called Gartner. They use it to describe new technology as it's introduced. So the x-axis here is time. The y-axis is visibility. So first something happens. Then you get this peak of inflated expectations. This is like, oh, big data is going to save the world, and it's going to cure cancer, and it's going to end poverty, and it's going to make everyone happy. And then people are like, hey, that's bogus. There's all these problems. This is garbage. We're just wasting our time. But then eventually people kind of realize, no, there are some useful things about this. It's not as great as we thought it was at the beginning, and it's definitely not as bad as we thought it was at the bottom. And so one way to think about what we're trying to do here at the Summer Institute is we're trying to push down this peak of inflated expectations. We're trying to pull up the trough of despair, and then we're going to try to get you here as quickly as possible. And so how do we do that? How can we create computational social science, both individually and as a community? So I think it's going to involve a lot of work between social scientists and data scientists. So social scientists, that's a term that has a relatively clear understanding to a lot of people. I want to say briefly what I mean by data scientists, because I don't mean just someone with a hoodie and a laptop. Although if you have a hoodie, that's totally cool. I love hoodies too. So what is data science? It's anything that's cool. More specifically, I think data science is, to me, this is the best paper that articulates what data science is. It's a paper by 50 Years of Data Science by David Donahoe. It just came out last year. I would really recommend reading this paper for anyone that's interested in sort of understanding the origins of the field. But Donahoe, the way he expresses it is it goes back to John Tukey. So you think of some of Tukey's work about like exploratory data analysis. Tukey has a paper from 1962 which sort of articulates a lot of what sounds like data science today. And he defines it, Donahoe defines it very broadly of learning from data. And so this then certainly includes statistics, it includes machine learning, but it also includes other things that are not traditionally fitting into these fields. So I think increasingly what people are finding is there's a part of learning from data that is not just statistics, as statistics is currently practiced. And it's not just machine learning as machine learning is currently practiced. There's this other stuff. And like, how can we bring this other stuff, sort of some of the stuff that happens right now backstage in research and bring it into the front stage and develop it as an area of research in and of itself. So I think it's a very exciting development. It includes statistics, and I think it includes much more. So definitely big tent on data science. And so I think data science alone is not going to be enough if we want to study social behavior. So there's this great magazine article by Chris Anderson in Wired called The End of Theory. Basically, he argued if you have enough data, then you're finished. Like everyone else, you can just go home. You don't need to think anymore. The data will just tell you. And so I think we all of us here know that that's not likely to be the case. But I think I'm really glad he wrote that, because I think that sort of does a good job of illustrating the sort of extreme view that some people are sort of, if you think of it as a continuum, like he's at the extreme of this continuum. And once you read that article, you'll see that a lot of the other stuff that you hear has echoes of that most extreme view. And I think we know that extreme view is not likely to be successful. And so I think that calls into question some of the other stuff that is a more polite version of that argument. And social science is not going to be enough. So if social scientists, if we continue to use the techniques that we're using and the data we're using, we're going to miss out on all this exciting stuff that's possible now. And so we're going to have to change as well. And so I think there's great opportunity for us all to work together and learn from each other. But there are differences in culture, and I want to talk a little bit about these because these are things that you will experience here during the Summer Institute. Often there will be group activities, you'll be partnered with people from different fields, and there will be misunderstandings. And so I want to try to get out some of what I see as some of the main cultural differences, so that to help make these misunderstandings less likely. So Hannah Wallach is a computer scientist who's gotten much more interested in social science now. She does great computational social science. And she overheard this conversation between two people, and someone said, "I don't get it, why is this research?" So you can imagine that if you're a social scientist, when you hear what some of the computer scientists here are working on, you might secretly be thinking that. You should not say that. You can say it in a polite way. And likewise, for the computer scientists here, some of you may not totally get what the social scientists are doing. And so Hannah has this nice way of thinking about these different styles. And so social scientists generally study social things. It's generally question-driven, like they care about the actual research question, not necessarily so much about the methods. It usually uses small design data sets, and it's generally focused on explanation, which is, it's hard to know exactly what that means, but that's the goal, to understand something. And she says, computer science, they generally study anything. So some computer scientists maybe do biology and social science and neuroscience and just would do whatever. Methods driven, so the question is maybe less important than the method. Often using found data and often focused on prediction, not explanation. And so these are some themes that you'll maybe see as you talk to each other about your work and as we learn more about different pieces of work. So try to keep in mind that different people have different styles, and no style is necessarily better than the other. Like if you're a social scientist, maybe your style's not the right one. Maybe you should be doing stuff more like a computer scientist. And if you're a computer scientist, same thing. So try to be open to other people's style. Another important difference is this glass. So this glass, I could ask, we could do a show of hands. Actually, let's do a show of hands. We have time. OK. So I'm going to ask you, how many people think this glass is half full? And how many people think this glass is half empty? All right, so half full, raise your hand. Half empty, raise your hand. OK, good. So I wasn't actually tracking. I should have been tracking better. But what we often see is that social scientists, I would say, tend to be glass half empty about research. So in other words, I think social scientists are often much more critical of research and like to point out flaws in research. So this question is not a good question. The data doesn't match. The construct validity is not right. How is that sampling done? All this stuff. Data scientists tend to be more glass half full, like, look at this, isn't this cool? I totally solved this problem, it's awesome. And that's great too. And so I think though the glass is really, it's both half full and it's half empty. And we need to be able to see both of those things. And so if you tend to be a glass half full person about research, try to be a little bit more of a glass half empty person. And around here, there will be people who are more like that, and try to learn from them and see the world the way they see it. See how they notice problems in research, because seeing those problems is really valuable. And if you tend to focus on the problems, that's great too, but try to see also that the glass is half full, and spend some time with the glass half full people so that you can see all of this exciting stuff. So that is one of the ways that we can work together and learn from each other and be sensitive to the differences in the intellectual traditions that we're all coming from. So that is a sort of way of kicking off sort of what we think computational social science is and how we can work together. And now Chris will talk more about why we did the Summer Institute.